Okay, we have all this information. We're going to make a nice huge table here. For the table, when you're sketching, what you're going to do, the first part is your intervals. And then the second part is going to be f of x. Then you're going to have f prime x. Then you're going to have f double prime x. And then you're going to have characteristics. So, to do this, our intervals okay, looking at all my data, I have some vertical asymptotes which we're going to put in our interval. I have some critical numbers and points of inflections. So looking at all this data, the square root of 12, well, that's between the square root of 16 and the square root of 9. 16 is 4, 9 is 3. So is this bigger or smaller than 2? It's bigger than 2. So my first interval is going to go from negative infinity to probably the negative square root 12. That'd be correct. Out of my values, is that my smallest? Okay. And then you put x equals negative square root 12. You first do the intervals, and then in the intervals you actually need to plug in the value of that spot. It's a little bit extra. My next interval is negative square root 12. Would it be to negative 2? Does that look right? And then we have x equals negative 2. And then we have negative 2 to what? What's my next one? 0? Does that look right? I think it's 0. Then we have x equals 0. And then we have 0 to, is it 2? 0 to 2. And then we have x equals 2. And then we have 2 to, is the last one square root 2, square root 12? Hope I'm not missing something. And then we have x equals square root 12. And then we have square root 12 to infinity. Woohoo! That's going to be fun. Here we go. Now, what we need to do real quick, and I forgot to write these down, is we probably want our derivatives to look at. Okay? We have f of x is, again, x cubed over x squared minus 4. You have f derivative x is equal to x squared, x to the 4th minus 12x squared over x squared minus 4 squared. And you have the second derivative of x is equal to a simplified version of 8x times x squared plus 12 over x squared minus 4 cubed. Okay, those three, you need those three on this page because for all these columns, aren't we plugging into those three things? Okay, guys, hang in there. Here we go. Oh, can I put 0, 0 right there? Woohoo! Got a point. Yes. Okay, here we go. For the interval, what's an easy value between negative infinity and negative square root 12? Would negative 4 be a good one? Now, I'm just going to put, do I need to actually find the value at that? No. So, but I'm going to be plugging in negative 4. When I plug in negative 4 to the first derivative, look at this. What's a negative 4 to the 4th? positive. Negative 4 squared, positive. But which one? That's kind of annoying. Let's also, okay, negative 4 down here. Is this bottom going to be positive? So the bottom's positive. The question is, when I put negative 4 here and negative 4 there, is negative 4 to the 4th or negative 12 times 16? Which one's bigger? X to the 4th is bigger when you plug in negative 4. So this is going to be a positive. You just have to know, okay, negative 4 to the 4th is really big, and then 16 times 12 isn't as big. When I plug it into the second derivative, right here, negative 4, that's going to be negative. This will become a positive, and then the bottom, won't that be positive? So you have a negative times a positive over a positive. Isn't that going to be negative? When we plug in the square root negative 12 right here, we're plugging in the original. Yes, that's going to be fun to do. And let me just tell you the answer. Negative 3 square root 3. Or negative square root 27. Are you guys okay with that? Isn't this 0 because wasn't it a critical number? And here, if we plug in that ugly number right here, okay, well, if it's negative, won't that become negative? Positive, positive. So won't this be a negative? If you look at this second derivative down here, if you plug in the negative, it's going to become